Okay, it's video T3A. We're going to talk about graphing trig functions, and this video is going to cover specifically graphing sine. So, first thing we're going to do is just graph the parent function, just y equals sine x, nothing else special, and using the following values for x. So I want you to use these values. So we're going to make a table, and I'm going to plug 0 in for x, sine of 0, sine of pi over 2, sine of pi. Okay, and I'm going to get the y values straight from the unit circle. So if sine of 0, remember 0 on the unit circle, and sine is the y value. So sine of 0 is 0. Sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. And sine of 2 pi is 0. That's coming from the unit circle. So when I go to graph this, I would point at 0, 0. Pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So I end up with this wave shape. Okay, and this pattern would continue. That wave is going to continue. This is what the graph of y equals sine of x looks like. And we have some key characteristics of this graph that we need to identify. First is called the amplitude. This is also the height of the wave. Okay, so if I'm looking at here from the middle of it up to the top, that is a height of 1. So this has an amplitude of 1. All right, period is the distance needed to complete one cycle. So if I look at this graph, one cycle, if it starts at 0, it goes up to the top of the wave, down to the bottom of the wave, and then back to 0. That is one cycle. So the period of a sine graph, of this sine graph, is 2 pi. That would be the period. All right. Phase shift, okay, this is a horizontal shift. So if we did something, remember we just graphed the parent function. So if I did something to move that parent function to the left or to the right, that is called a phase shift. And then vertical shift is exactly what it sounds like if I move that wave up or down on the y-axis. So you have a couple pages there where it gives you some different transformations of the sine graph to do. What I want you to do is on every graph, I want you to graph the parent function. So I have the original y equals sine x in blue, and then whatever I gave you on that graph, do that maybe in a different color if you have colored pencils or something, and use the x values that I told you. So I want you to graph those 4 graphs, I think it is, and look at the different transformations, what happens to the graph when we change the numbers in the equation. Okay, so we made some different changes here. When I put the 2 out in front of the sine graph, it changed the amplitude. It changed the height of my function. All right. When I added it at the end, that is a vertical shift. It moved the entire thing up the y-axis. Okay, when we have something inside parentheses being added or subtracted, that causes a phase shift. Okay, if the blue is my parent function, the green is just, it shifted over 1 mark on my x-axis. So that was a phase shift. And the last one might be kind of hard to tell, but when we multiply the variable x times something, that changes the period. All right, because here I have the parent function. This from 0 to 2 pi completes one cycle, goes up to the top, down to the bottom, back to where we started from. But the green one, my new one, goes up to the top, but it never goes down to the bottom of the wave inside that 2 pi. So this made the period larger. It stretched my graph out. So this is what we call standard form of a trig function, of a sine graph. All right, so there's 4 different things we can change. We can multiply in the front of the sine, we can multiply the variable, we can add or subtract inside parentheses, and then we can add or subtract outside of parentheses. So if I do this, it changes the amplitude. If I put something here, it changes the period. If I put something here, it causes a phase shift, and if I put something out here, it causes a vertical shift. Okay, now here's the thing. I gave you on these graphs, I gave you the 5 key points. I gave you 5 x values to plug in. From now on, that's not going to be the case. You're going to have to pick the 5 x values. So I'm going to show you a real easy way to pick them, all right? And here's some other things that you need to find. So period, you need to know this. For sign, a lot of times they use the letter T for period. I'm not really sure why. It doesn't make sense, but there it is. So period is equal to 2 pi over b, and b is that number that's inside the parentheses multiplied by the variable. Okay, so whatever it is in that equation, 2 pi over b will give you the period, the time it takes to complete one cycle. All right, and then our 5 key points, here's how this is going to work. For sine, the first key point, all right, is going to be bx minus c, so the part of the equation that's in parentheses, equal to 0, and then you are going to solve for x. That is how you're going to get each of your key points. All right, so this is going to give you the first one, and then we're going to find something called the interval. All right, and the interval is just, we're going to take the period, so t, or the period, and we're going to divide that by 4. Okay, and every time I want another key point, I'm just going to add this interval so that it makes sure that my points are evenly spaced out over the period of the graph. So let's look at an example. If I'm going to graph y equals 3 times sine of x minus 2, okay, the first thing I need is my first key point. Alright, so my first key point, and remember for sine, it's bx minus c equals 0. So in this case, bx minus c, the inside the parentheses part, is x minus pi over 2. Equals 0, and I'm going to solve for x. So I would add pi over 2 to both sides, so I would get x equals pi over 2. So when I go to make my table, all right, pi over 2 is going to be my first point. All right, then to get the others, we have to find the interval, and to get the interval, I need the period. So period, remember, is 2 pi over b. In this case, b would be 1 because there's no number in front of the x. So 2 pi over 1 or just 2 pi. So that's my period. All right. And my interval then is my period divided by 4. I'm going to break it up into 4 pieces. So 2 pi over 4 would simplify to pi over 2. So I'm starting at pi over 2, and every time I want another key point, I'm going to add pi over 2. So pi over 2 plus pi over 2 would be pi. Plus pi over 2 again, 3 pi over 2. Again, 2 pi. And one more time, 5 pi over 2. And I stop when I get 5 points. 1, 2, 3, 4, 5. So for sine, we need 5 points. And then for the y values, okay, I would plug in pi over 2 here, and I would get a y value. So I plug pi over 2 minus pi over 2 is 0, sine of 0 is 0, times 3 is 0. But I'm going to show you a little shortcut. If you pick your x values this way, what we've done is match them up with the parent function so that the y values are always going to follow that same pattern. Okay, so in my parent function, it went 0, 1, 0, negative 1, 0. Okay? The only way that's going to change is if I have something multiplied at the beginning or added or subtracted at the end. So in this case, all of my parent function values are going to be multiplied by 3 because we multiplied this whole thing by 3. So I'm just going to take each of these and multiply them by 3, and that's the only change that I need to make. So when I do that, now my y values that I get are 0, 3, 0, negative 3, and 0. Alright, and that's the process that you're going to repeat every time. Find your first key point, find the period, find the interval, add to get your 5 key points, okay? It's always parent function values times anything out here or plus or minus anything out here. Those are what are going to change your y values, and that is how we go about graphing sine.